This is probably the most frustrating problem in our whole manufacturing process. And it comes from our simplest yet most sophisticated product ever, the BareBag Nano. It is this simple disc that's been bothering us for the past year. So the problem when manufacturing this disc is to get the tolerance just right. You see, the disc is mainly made of two parts. So when these two parts come together, they will form this gap that sometimes, if treated not correctly, could cut papers. And the reason for that is we figured the shrinkage rate. So you see, the ring has a fairly small volume compared to the big base. And when the big base was still liquid, when it was injected into the machine, it has a much higher shrinkage rate compared to the small one. Therefore, these two models cannot have the same dimensions because the bigger one will actually shrink to become smaller than the ring, causing a really sharp edge because the smaller ring is popping out a little bit than the bigger base. So we had to change the dimension of the base just slightly bigger, about 0.05 millimeter bigger than the smaller ring. So when it shrinks, they actually becomes more similar than before. So the difference of their height becomes smaller. It actually feels smoother when you are touching the edge. Another thing about the disc is that it's super easy to scratch because, it's designed to be this hook that you can hang things onto probably 10 to 20 times every day. So it needs to be much more durable than that, much more scratch resistance. Before, we used this super durable material called 100% recycled PA6, which is a nylon material that's so strong and durable, but so soft that it's easy to scratch. We like this material, but fortunately, it did not withstand our test of scratching. So we decided to move on to this ABS material, which is a more traditional plastic. This increased stability really helps the injection molding process to be more consistent because we get back to the problems of dimensions. This consistency really helps these two parts maintain almost the same diameters every time they are produced. Another problem that we found during the manufacturing process is that the Nano's inside space could be sometimes occupied by the rotating mechanism. It's because these rotating parts sometimes are taking too much thickness, so the card actually hit the mechanism and stop there. So we want to prevent this from happening for good, and we extend the total length of the card holder. So the card, no matter where it hits, it's always going to be fully inside the housing. So those are the major updates, or should I say the major solutions to the last minute problems that we found during the manufacturing process. And we truly hope this product could be a really helpful tool in your daily life.